The future of getting around arrived while you were sleeping. Somewhere in China right now, a regular person with zero pilot training just tapped a screen, picked a destination, and flew there. No joystick, no controls, no license, just a seat, a screen, and the sky. At the exact same moment, an independent team of Guinness World Records adjudicators was standing on a public road in China, certifying something the automotive world thought was decades away. A family sedan that just traveled 106 miles on a single gallon of fuel. Not a race car, not a laboratory prototype, a car a regular family can walk into a dealership and buy today. The walls between cutting-edge technology and ordinary life are coming down faster than almost anyone predicted. And the companies writing the next chapter of transportation are not always the names you grew up hearing. The truck that carries a plane and its trunk. Most companies trying to build a flying car end up with something that drives poorly and flies poorly because they are trying to force one machine to do both jobs at once. A Chinese company called Xpeng AeroHT looked at that problem and asked a completely different question. What if the car and the aircraft were two separate machines that worked together perfectly as a team? The result is a six-wheeled electric truck that looks like something out of a science fiction film. Tough, spacious, practical on the road, but hidden inside its cargo bay, folded neatly and waiting, is a fully electric two-seat aircraft. You drive to an open field, press one button, and the aircraft deploys automatically from the back of the truck, unfolding itself, preparing for flight, and launching into the air within minutes. Here's what makes this genuinely clever rather than just spectacular. Because the aircraft uses the same electric motors and battery technology already running in millions of conventional electric vehicles, the production cost stays surprisingly accessible. The single biggest barrier keeping flying vehicles out of regular people's hands has always been price. Xpeng AeroHT attacked that barrier directly by building on technology that already exists at massive scale rather than starting from scratch. The aircraft with no pilot and a government certificate to prove it is safe. The EH216S removes the pilot entirely. You sit inside, select your destination on a touchscreen, and the aircraft flies you there on its own. No stick, no wheel, no pedals, just a seat, a screen, and wherever you need to go. What makes this genuinely historic is not the technology itself, it's the paperwork. In October 2023, China's Aviation Authority issued this aircraft an official type certificate, which is the highest level of safety approval any aircraft can receive anywhere in the world. Government inspectors examined every component of the design, tested it under demanding conditions, and officially confirmed it was safe to carry real human passengers. That made the EH216S the first fully autonomous passenger-carrying drone in history to receive that certification anywhere on Earth. Not a concept, not a prototype, a certified aircraft. It runs on 16 independent rotors across 8 folding arms, carries 2 passengers, and is monitored by a ground control center throughout every flight, meaning human operators can intervene if anything unusual happens. But in most flights, the AI handles everything from takeoff to landing without any input at all. The fact that a government signed off on autonomous passenger flight is a line that once crossed does not get uncrossed. 5 jet engines strapped to a human body. This one takes the concept of personal flight in a direction that is equal parts terrifying and brilliant. The Gravity Industries Jetsuit, built by British inventor Richard Browning, uses 2 jet engines mounted on each arm and 1 on the back. Combined output over 1,000 horsepower, which is more than most sports cars produce. The pilot controls direction by moving their arms and shifting body weight. Lean forward to go forward, shift left to go left. It reaches speeds of 53 miles per hour and can climb to nearly 12,000 feet. The honest limitation right now is fuel. Each tank gives approximately 10 minutes of flight time, which restricts what the suit can practically accomplish today. But military and emergency response teams are already testing it seriously, imagining scenarios where a paramedic flies over gridlocked traffic to reach an accident scene in the time it currently takes an ambulance to move 3 blocks. And here's the detail that matters beyond the drama. Every single minute of flight generates data about how human bodies interact with personal flight at speed. Data that shapes safer, longer-lasting, more practical versions of this technology. The Wright brothers flew for 12 seconds at Kitty Hawk. Those 12 seconds changed everything that came after them. The flying vehicle that anyone can learn in under an hour. The Jetson One weighs 190 pounds, less than most motorcycles, runs on 8 electric motors, and reaches 63 miles per hour. In many jurisdictions, no pilot license is required to fly it. The reason that is possible is the onboard flight computer, which handles all the complex stabilization work automatically. Release the joystick mid-flight, and the aircraft simply hovers and waits for your next input. It essentially monitors itself while you focus on where you want to go. The company designed it around one specific goal: make personal flight feel as natural and approachable as driving a car felt to the first generation of drivers. Early owners have described it as among the most extraordinary experiences of their lives. The price remains high for now, but it is falling as production scales. This is a pattern that is repeated across every transformative technology in modern history. Electric cars started as expensive curiosities for early adopters and became the fastest-growing vehicle segment on Earth. Smartphones started as luxury devices and became the most universal tool in human history. The Jetson One is at the early adopter moment right now. 5 years from today, it will look very different in the market. The electric aircraft that flew from Washington to New York without fuel. The Autoflight Prosperity is not a personal flyer or a weekend toy. It is a large electric vertical takeoff and landing aircraft designed to carry multiple passengers on real routes between cities and across metro areas. It recently set the world record for the longest flight ever completed by an electric aircraft of its type, 155 miles on a single charge. That is roughly the distance from Washington, D.C. to New York City, flown without burning a single drop of fuel. For passengers, it works like an air taxi. You book a seat, board, and the AI flies you to your destination. What genuinely separates the Prosperity beyond the range record is how it handles emergencies. The engineers built multiple independent protection layers into the design. If a critical component fails mid-flight, the onboard AI can deploy a ballistic parachute within a fraction of a second and float the entire aircraft down safely. If the parachute is not needed but something still goes wrong, the system can execute a full emergency landing with zero human input. That level of built-in redundancy is precisely what will eventually convince ordinary commuters to trust an autonomous air taxi more than they currently trust the highway. And statistically, once this technology matures, it likely will be safer than driving. The racing league that is making future aircraft safer for everyone. The Airspeeder Mark III was built for the world's first flying car racing series. Pilots sit in remote locations wearing virtual reality headsets and race these aircraft through three-dimensional aerial courses at speeds up to 186 miles per hour. Think about that comparison for a moment. Formula One cars race at similar speeds on flat tracks surrounded by walls and barriers. These vehicles race through open airspace in 3 full dimensions, guided entirely by pilots who experience the flight only through a VR headset. Here is what matters beyond the spectacle. Every major racing competition in history has functioned as an engineering laboratory that eventually benefited everyone. NASCAR taught the world about tire performance and engine reliability under sustained stress. Formula One gave engineers carbon fiber and advanced aerodynamics that eventually found their way into ordinary passenger vehicles. The Airspeeder series is doing exactly the same thing for flying vehicles, pushing collision avoidance software, sensor arrays, lightweight materials, and battery management systems to their absolute limits in real competitive conditions. Every close call and every mechanical failure in those races generates engineering insight that makes the next generation of civilian aircraft smarter and safer. The American flying vehicle built around freedom. The pivotal Helix is American-made, weighs 254 pounds, uses 8 tilted rotors, and requires no pilot license under U.S. federal regulations for ultralight aircraft. The company says you can learn to operate it safely in under an hour, and that's not a marketing claim. The flight control software handles takeoff, landing, and stabilization automatically. You focus on direction. The computer handles everything else. What makes the Helix worth discussing alongside everything else in this video is what it represents at a larger level. The regulatory framework in the United States was specifically designed to allow people to fly lightweight aircraft without heavy bureaucratic barriers to entry. The Helix fits precisely into that philosophy. Meanwhile, across the Pacific, a parallel but equally powerful approach is developing through scale rather than individual freedom. In multiple Chinese cities, fleets of autonomous drones are already delivering hot food, medicine, and packages to automated neighborhood collection points at massive scale, with no human delivery driver involved at any point. That delivery network isn't just a convenience delivery system, it's a training ground. Managing thousands of small autonomous aircraft flying through city airspace every single day is building the coordination software, traffic management systems, and real-world operational data that will eventually guide hundreds of personal flying vehicles through those same skies safely. The delivery drones are the practice run. That practice run is already happening at enormous scale. The full-size hybrid aircraft that replaces the airline for regional travel. The XTI TriFan 600 is not a commuter hopper or a weekend novelty. It is a full-size hybrid aircraft designed to replace short and medium-distance regional air travel entirely, and its design is unlike anything that came before it. 3 ducted fans power the aircraft. 2 sit inside the wings and can physically rotate 90 degrees. At takeoff, they point straight up, lifting the aircraft vertically like a helicopter. Once airborne, they rotate forward, and the aircraft transitions into high-speed horizontal flight like a conventional plane. A 3rd fan in the tail manages directional control throughout the entire process. This means the TriFan 600 takes off from a rooftop helipad, a corporate parking lot, or private property. No airport, no runway, no terminal lines. Once in the air, it carries 6 passengers at a cruise speed of 380 miles per hour, reaches 30,000 feet, and covers a range of nearly 1,500 miles. A road trip that currently consumes 5 to 6 hours of life in heavy traffic becomes a 90-minute door-to-door flight. That change does not just make travel faster, it reshapes where people choose to live, where businesses choose to locate, and how entire regional economies connect with each other. The engine that stopped an entire industry cold. At the Beijing Auto Show in April 2025, a Chinese company called Geely walked onto the stage and displayed a single number on the screen behind them. The number was 106. As in 106 miles per gallon, certified and verified by Guinness World Records adjudicators who were physically present on a public road in China for the entire test. Not a closed circuit, not a laboratory simulation, a real road in a real mid-size family sedan with independent observers watching every measurement. To understand why that number made engineers across 3 continents genuinely silent, you need to understand one thing about how combustion engines work. When fuel burns inside an engine, only a portion of that energy actually moves the vehicle forward. The rest escapes as heat through the exhaust or gets absorbed into the engine metal. The percentage that becomes actual forward motion is called thermal efficiency. The engine in the average American car sitting in most driveways right now converts approximately 30 to 35% of its fuel into motion. Everything else is wasted heat. Toyota, the company that invented the modern hybrid and spent 30 years perfecting it, maxed their most advanced engine at 41% thermal efficiency. For years, that was considered the gold standard, the number every engineer aimed for and nobody matched. Geely's new engine hits 48.41%, independently certified, verified by outside observers. For context, the engines inside Formula One race cars, the most sophisticated combustion engines ever built, rebuilt after every single race, costing millions of dollars each, operate at around 50% thermal efficiency. Geely built an engine for a family sedan that is within touching distance of Formula One performance, and they're putting it in a vehicle that costs less than $10,000. When that engine pairs with a 308 horsepower electric motor and an AI energy management system that decides in real time whether to use the engine, the battery, or both, the result is 106 miles per gallon on a public road in a car any regular family can actually buy. In 2024, Toyota drove a Prius from Los Angeles to New York City to demonstrate peak hybrid efficiency. That famous drive averaged 92.9 miles per gallon and was celebrated across the automotive world as a landmark achievement. Geely's system beats it by more than 12% in a vehicle that costs a fraction of the price. Why this is all one story? Geely does not only sell cars under its own name, it owns Volvo, it owns Polestar, it operates a major luxury joint venture with Mercedes-Benz, and actively licenses its powertrains to Western brands through its Fly Me Auto alliance. That means these ultra-efficient engines will start appearing inside European and American vehicles within the next few years, regardless of what traditional legacy manufacturers choose to develop on their own. Meanwhile, BYD, which recently passed Tesla to become the world's top-selling electric vehicle manufacturer, launched its own fifth-generation hybrid system running at 46.06% thermal efficiency, with a top model that travels over 1,300 miles combined on a single tank and full battery charge. That's the driving distance from Miami to Boston without a single fuel stop. The engines inside vehicles made by Ford, General Motors, and Stellantis are still mostly operating at 30 to 35% thermal efficiency. That gap does not close quickly. Redesigning an engine platform, retooling a factory floor, retraining engineers, and bringing a new product to market takes years. The distance between what the most efficient hybrid powertrains are doing and what conventional combustion engines are doing is growing, and it's growing fast. 8 flying vehicles already real and certified, 1 engine that officially rewrote the record for what a car can accomplish on a single gallon of fuel. These are not two separate stories, they're part of the same shift. The walls between what counts as advanced technology and what ordinary people can actually afford and access are coming down simultaneously in the air and on the ground. Transportation is doing to itself what the smartphone did to cameras, maps, music players, and wallets. The version that exists 10 years from now will look completely different from what we drive and fly today. Before you go, here's what I genuinely want to know from you. Between a flying vehicle that lifts off from your own driveway and an engine that carries a family sedan over 1,000 miles on one tank, which one changes your actual daily life more? Drop your honest answer in the comments. Hit like if this changed how you see what transportation is becoming. Subscribe to AK Truthix. We cover these shifts before they reach the mainstream. Notifications on. I'll see you in the next one.